In this video, we're going to talk about surface area and volume of spheres. So first off, let's go ahead and fill in these different blank spaces. So first off, a sphere, think of it as like a baseball, is a set of all points in space that are equidistant from a given point. And the center of a sphere is the given point from which all points on the sphere are equidistant. So just think of a baseball, the very center of it, it's going to be the same distance to your radius. It's going to be the same distance all the way around. So the radius, since we were just talking about that, of a sphere is a segment from the center to a point on the edge of the sphere. And our diameter, again, would be all the way across of a sphere is a chord that contains the center. So realize the chord has to go, or the diameter has to go through the center. That's the big part, so not just anywhere in it. And a hemisphere, you're going to see this a couple times, is when you have a sphere and you cut it in half. So it's half of a circle. For our two formulas, the surface area of a sphere is 4 times pi times radius squared. For the volume of a sphere is 4/3, so as a fraction, times pi r cubed. So make sure you get those correct on there. And if you notice my picture over here, that there is my radius, so all the way across would be my diameter, and sometimes you might be given that. Once we get into the solving, so find the surface area of the sphere, and if you notice over here, my radius is 7, and we're finding surface area, so you want to write down your equation first, or the formula you're going to use, so 4 pi r squared, and all we need is the radius. So we can go ahead and plug our numbers in. So 4 pi 7 squared. If I multiply my 4 times my 49, I end up with 196 pi. So when I simplify that, I get 615.752, and this would be centimeters squared because you've got area, so you want to do squared with your final answer. When we're doing volume, we're going to do it to the cubed power. For the next one, it gives us the surface area itself is 110.25 pi. They're saying that that is the surface area, so we need to set it equal to the actual equation for surface area so that we can solve for the radius. Once we have the radius, then we can double it to find the diameter. So when we're solving this, if you look on both sides, if we divide both sides by pi, the pi symbols are going to cancel each other out, and that means we're going to have 110.25 equals 4r squared. So next we can divide by our 4. So r squared is going to be 27.5625, and to get rid of our squared, remember the opposite of that is square rooting it. So the square root of that gives us 5.25 exactly. So to find our diameter, we need to multiply that by 2. So our diameter is going to be 10.5, and this would be feet. And that's it for that question. All right, so next we're going to do volume. So our volume equation, remember, is 4/3 pi r cubed. And if you notice, our diameter over here is the 61.9, and we need the radius. We need to divide that in half. So divided by 2, and that gives us 30.95 for the radius. And now we can plug all our numbers in. So we have 4/3 pi times 30.95 to the third power. And when we type that in a calculator, we end up with 124,808 thousandths, and this would be inches cubed, and it is cubed because we have volume, so just realize that. The nice thing with these last two questions and with volume itself specifically is for volume, if you have composite figures, you don't have to worry about the parts that they share. That is still just the space that they take up inside for the volume, so we can just find the area, the volume of each of them individually, and then just add them together with no extra little pieces. So in this first one, we have a hemisphere, and So my hemisphere right here is going to be half of a sphere. So there's my equation for my hemisphere. Then for my cylinder, take that one over here. So my cylinder, we just have, remember, capital B times H. But realize that your area of your base is a circle, so it's really pi r squared times the H is really what we're going to do. So let's go ahead and plug all of our numbers in. So we have 1/2, 4/3 pi. My radius is 5.8. And let's see, for my part in orange, for my circle, we've got pi. The radius again is 5.8 squared, and then times my height, which is 14. So it's the height of the cylinder. All right, so when we plug these numbers into our calculator, if we just do this part alone, you should get 408.642. If we do the orange part all by itself, so my cylinder, I get 1,479.564. So then our final answer needs to be combining these two pieces together for the total volume, and we get 1,888.206, and this would be in feet, and since it is volume, we're going to have cubed as our units. All right, so for the next one, we have surface area and volume, so we're going to divide this up. So on the left side, we're going to do surface area. On the right side, we're going to do volume. So for the first volume, if we do our hemisphere again, we're going to have half of our 4/3 pi r cubed. So that's our hemisphere right here. And then we need to add that to my cone. So my cone, remember, is 1/3 capital B times H. And remember, the capital B is really pi r squared because the base is a circle, and then times my H. All right, so let's plug these numbers in. So we have 1/2, 4/3 pi. The radius is 6, so 6 to the third power. And then for my part in orange, I've got 1/3 pi. My radius again of my cone is still the 6. So 6 squared. My height of the cone is the 17. All right, so when I combine these different numbers together, the first one I get is 452.389. And always double check to make sure you're getting the same numbers that I do, because part of it is also typing it in the calculator correctly to make sure you can get the final answer. So when I add these two together, I get 1,413.716, and this is volume over here, so it needs to be feet cubed. Okay, so going back over to the surface area side, we have a cone and we have the hemisphere. So if you realize for both of them that the circle is not showing, but on the cone, remember we normally have pi r L plus pi r squared, and we do not have the base because it is covered up. So I'm eliminating that part of it. For my hemisphere, that I have my 4 pi r squared, and all I have to do is take half of it because the circle would normally be showing, would I have to add that back in, but in this case it is not showing, so I don't have to worry about that. It's just half of my sphere. All right, so the part that we are missing is the slant height, and that is my L. So I need to use Pythagorean theorem with my 6 squared plus 17 squared equals my c squared, and I get, let's see, 325. So that would be the square root of that would be this slant height. So that's my little L. So pi times the right radius is 6 times the square root of 325. There's my L. And now I can do my part in blue. So 1/2 4 pi. My radius is 6 squared. There we go. So my part in purple, when I type this in the calculator, so pi times 6 times the square root of 325, I get 339.815. When I do the part in blue, so my hemisphere, I get 226.195. So we need to add these two pieces together, and I get 566.00967, and I did this because since I need to look at the 6 to bump that 9 up, it really becomes 566.010, And this is surface area, so this would be feet squared for the surface area piece.